Hi students, my name is Emma Reed. I'm an 8th grade math teacher, and today we are working on day 4 of Unit 8, the Pythagorean theorem and irrational numbers. And we're working on side lengths and areas part B. And our big question for today is, what is a square root? So by the end of this lesson, you should understand what a square root is and recognize it when you hear it. Moving on to our introduction/launch, your warm-up today is to think back to what you did yesterday and answer what is the area of square A, what is the area of square B, and what is the area of square C. So pause, take your time to think, and fill out the blue rectangles describing your thinking. Once you've had some time to think about your launch, move ahead with me to slide B. Now we're taking that same image and we're going to think about what is the side length of square A, what is the side length of square B, and what is the side length of square C. So pause and think about that one. And when you're ready, we'll move ahead to slide C, where we're going to start our Explore section. In our Explore section, we're going to fill out two tables that compare the side length of a square to the area of a square. So our directions say the side lengths and areas of various different squares are listed in the table below. Determine the missing values. So you're either going to be starting with the side length and figuring out the area, or starting with the area and figuring out the side length. So pause, think about how to fill out the table. Maybe start with what you know for sure. You don't have to fill it out in order. So pause and think. And if you've had some time to think and you still need a little bit of extra help, I'm going to show you a place that you can go if you're someone who learns really well from visualizing. I'll show you where you can go next. If it made sense to you, feel free to skip ahead. I'll put what minute to skip to on the screen. But if you need some extra help visualizing this, you can go along to a new website with me called Polypad, and I'll show you that website now. So right now I'm at mathigon.org/polypad. And to help you think about area, I suggest you go to the grid section, make a grid. Then you can see we have all these shapes over here. Since we're working with squares, we can take these squares for our area. And the first area we were given was 1. So if you imagine this is a square with an area of 1, what would the side length be? And then the next square that they asked us was a square with an area of 4. So I'm making a square with an area of 4. Ask yourself, what's the side length in this case? And I believe that the next square that they asked us about was a square with an area of 9. So I'm going to make a square with an area of 9 now. And then you can ask yourself, well, what was the side length in this case? And you can keep building whatever areas you need to figure out how to get from the area to the side length. And if you understand how to get from area to side length, but you're struggling with getting from the side length to the area of the square, what we can do is we can imagine that each of these units, instead of being 1, let's imagine that each of these units is going to be a length of 1/2. So we can actually reuse this same square to try to answer the question of what would the area be if the side length was 1.5 units. So again, we're going to think of each of these lengths as 1/2. So we can say this whole length is 1.5. And so think about, what do you know about squares? What's special about them? And how could you use this visual to help you figure out the area when a side length is 1.5? And you can think of each of these little squares as a half unit squared. So imagine, what would that be? How could this help you find your area? So now let's go back to the table. Hopefully this helped if you weren't sure how to start. Again, you can get to this screen under mathigon.org/polypad. So we're back at our Explore slide C, and if you've decided what you think all of the areas are based on the side lengths and all of the side lengths are based on the areas, we're going to look on slide D, and now we're going to actually plot the points. So we're looking at this graph for a relationship between the side lengths and the area in square units. So our side length is going to be our x, our independent variable, and the area is going to be our output or our dependent variable, or y. So plot those points based on the previous slide. And then you can use the graph to figure out the approximate value of the square root of 45. So we can use this symbol here, which is called the square root symbol, to demonstrate going from the area. So this is the area, and the answer to that would be the side length. And when you've had enough time to think about slide D, we'll move ahead to slide E. And on slide E, you're going to insert the areas you calculated on slide A and your estimates from slide B, and then use the graph on slide D to complete the final row of the table. So you're looking at how did your calculation on slide A compare to your estimate on slide B, and then to your prediction based on your graph on slide D. And then once you've filled in the table, you're going to answer the question, how do your estimates for side length on slide B compare with the side length values indicated on the graph? So take some time to fill out this slide. And when you've answered all of the blue space, you'll move ahead to slide F and determine what is the area of this square. You're also going to answer between what two integers is the side length of this square, and how can we denote the exact side length of this square. Finally, once you've had time to think on slide F, we'll move on to our summary section, where you're going to answer the question, what is a square root? Thank you for joining me today. I hope that the Polypad was helpful if you weren't sure how to visualize area, and have a very nice day.